So let's apply the t-distribution to the example that we had previously, where we were trying to estimate the willingness to pay for a certain product, and we were trying to estimate the population willingness to pay. So we want to recalculate the confidence interval for the mean willingness. So we're right here to pay for this new consumer product. Well, we're going to assume that our n, we used an n of 36, so our degrees of freedom would be n 36 minus 1. For some reason, our n has changed, so the n here is 12, so n minus 1 would be 11. So we need to find the t-distribution or the t-statistic for degrees of freedom of 11. Going to the back of your notes packet, you'll find the tables. The first table is the z table. The second table is the positive z-scores. And then the third table is the t-distribution, or critical values of t. So we're going to assume a 95% confidence interval. Now, a 95% confidence interval, another way to say it, is that we have 5% area in the two tails. So there's 2.5% on the left and 2.5% on the right. So we could call this middle column, and I can't write this on this table right here, but we can call this middle column the 95% confidence interval. Okay, this would be the 98% confidence interval. This would be the 99% confidence interval. And then this one here would be the 90% confidence interval. We're primarily going to be using the 90, 95, and 99, and we'll discuss more about why and when you would use it. As a rule of thumb, if it doesn't explicitly say what the confidence interval should be, a 95% confidence interval is generally accepted. So we can see in this case that we have, a degree of freedom of 11. Kind of fickle. So at a degree of freedom of 11, we would come over to the 95% confidence interval, and we see that our t-distribution is 2.201. Now in the previous example, we used 1.96 as our z-score. Now we're going to increase that because the t-distribution has got slightly fatter tails, so we have to go further from the mean. Well, what does that mean? It means that our confidence interval is just slightly wider. So now 2.201 is used instead of 1.96. And we find that we are 95% confident, given the t-distribution, that the true population mean falls somewhere between $27.07 and $30.13. Compared to our larger sample, which was $27.82 and $29.38, we can see that because of our sample size was smaller, we get a smaller distribution. Now let's take a look at an example of how we can do this in Excel. And I have this example in the notes. The data that we're going to use doesn't perfectly match this. We're going to be using the data set in lab data sets called attitude.xls. Attitude is a data set that sampled several people and asked them, how do you feel about different malls? So we have Springdale Mall, we have Downtown Mall, and we have Westlake Mall. We want to estimate the population mean, and so we can calculate the standard deviation, we can calculate the average in our sample and calculate a confidence interval, but Excel has a tool already built in. Once again, we go to our data analysis, And we're going to use descriptive statistics. Now, we've used descriptive statistics before. This time, let's just estimate the population's perception of Springdale Mall. The Springdale Mall is based on a Likert scale where 1 means that you don't like the mall, a 5 means that you really like the mall. And I'm going to capture here in the inputs all of our observations. So it looks like we've asked 200 people, how do you like Springdale Mall? We want to estimate the population's perception of the mall. We do have labels in the first row. I'm going to allow this to go to a new worksheet. We want the summary statistics, but we want one additional statistic. So we're going to click on this confidence level for the mean. And you can see by default it's set at 95%. We click OK and it will give us the output. So on average, people like the Springdale Mall at a measure of 4. So it's not a 5, but it's not a 1. It's something higher than the middle, or the 3. 3 is kind of a neutral area. But we're given one additional statistic here at the bottom. So if we wanted to know the upper confidence level and the lower confidence level, this confidence level term right here is that most likelihood error. So the most likelihood error is defined, if we want to know the upper confidence level, we would take the sample mean plus the error term. If we want to know the lower confidence level, we would take the mean minus the error term. So in English terms, we would say we don't know what the population perception of Springdale Mall is, but we are 95% confident if we could measure the population's perception. So if we could ask every single person in the population, how do you like Springdale Mall? We would be 95% confident that that population mean would fall somewhere between 3.98, 3.99 at the lower limit and 4.2 at the upper limit.